Today we're going to demonstrate the pin and socket set from Moore Test and Measurement on the Moore CT100B. Let's get started. Always remember to properly discharge static before connecting to any high-frequency test equipment, and never connect to live equipment. The Moore pin and socket set was developed to meet the needs of the aircraft industry and has found use in multiple applications where multi-pin connections are used. Multi-pin connectors are everywhere, and testing them can be quite challenging, frustrating, and seemingly impossible if using other methods. Alligator clips, probes and hooks, tweezers. None of them have matched impedance to ensure max power transfer and the best measurement possible. That's where the Moore pin and socket kit comes in. The pin and socket kit consists of 4 impedance-matched pin probes, 4 impedance-matched socket probes, BNC and SMB connections, and a quick connect cable. The Moore pin and socket set allows a technician to easily test cable pairs and cable to ground in a multi-pin connector. Here we have a set of alligator clips connected. You can see the amount of distortion from the clips, and they aren't even connected to a device yet. Probe hooks aren't much better, but they may let us clip to a pin easier than alligator clips. Here's some multimeter probes. And we even have some electronic test tweezers. And as you can see, the distortion is quite massive. Connecting the socket for the pins that we'll be testing, you can see a dramatic difference. A clean trace through the probe to the open we have here at the tips. Using this sample from Rolls-Royce, we're going to test pins A and B and compare those to pair S and T. As you can see, there's a clear difference in length between A and B pair and the S and T pair. This would indicate a problem that would have an open that would need either a repair or a replacement. And now we're going to look at those other methods. The hooks were able to connect to these pins, but they were hard to get on and stay on. If the pins would have been larger or smaller, it might not have worked. We can see the comparative trace, and it's quite distorted. Even worse with the alligator clips, as they wanted to short against each other. The plug assembly itself or the neighboring pins. And the comparative trace is even more distorted than we had with the hook probes. Using the tweezers as pins gave us a very distorted trace on the other side, where the hooks and alligator clips couldn't go. Comparing the hook probes to the pin and socket set, as I line up the traces to match time, you can see that the trace from the hook probes is severely distorted in the first half of the cable being tested. It would be difficult to see if there were any defects in that portion of the cable compared to the trace using the pin and socket probes. To use the pin and socket set, select the size of pin or socket probe that will be needed. Today we're going to use the number 20 socket probe. Connect the cable provided to the probe. Connect the cable to the desired BNC adapter. After verifying power has been disconnected and everything's powered down, short pins to discharge the static. Connect the probe to the desired pins, then connect to the CT100B. I've connected to the S&T pins as our known good pair, and we'll compare this trace to some other examples. Pressing the orange AutoFit Help button brings up the built-in Help menu and gives you the option to select AutoFit from the Quick menu. The AutoFit feature will show the entire trace from where it leaves the CT100B, through the connection we made with the probe, and all the way to the end of the cable. To give us an accurate length, I've set the VP for this cable at 0.659. And AutoFit places the second cursor at the end of the cable, as you can see here, where the impedance climbs sharply. I'm going to save this trace by first pressing Scan, then Start Scan. This turns the live trace red and locks it in place, where we can then press Save. I've attached a USB keyboard to speed up the process of naming. You can also choose to use the on-screen keyboard. And I'll name this something like ST Pair Test Good. And now you can press OK or just hit Enter on your keyboard. And you can see the name is saved to the trace on the screen. I'm now going to switch to pair A and B. Now this one looks rather different than our known good. It appears to have a short several inches from the end. Our focus would then turn to looking for physical damage about 8 to 10 inches from the other end. And there you have it, the More Pin and Socket set, helping you save time and money detecting cable faults quickly and easily. Subscribe to our YouTube channel, check out our website at moretm.com for more updates, and we'll see you next time.